Let's get right into it. You've been lied to, not in a malicious, the world is secretly run by lizard people kind of way. Though, let's be honest, the jury's still out on that one. No, this is a much more fundamental lie, one that's been drilled into your head by literally every sci-fi movie ever made, except for maybe that one artsy film you pretended to understand. The lie is this: space is silent. It's the perfect backdrop for dramatic tension, right? A lone astronaut, floating in the void, the only sound being their own panicked breathing as the, whatever it is, slowly drifts into view. It's elegant, it's poetic, and it's completely, utterly wrong. Sure, in the way you're used to, space is silent. Sound, as your high school physics teacher probably explained before you fell asleep, is a mechanical wave. It needs a medium to travel through: air, water, the desk you were napping on. The vacuum of space is, by definition, empty. There are no air molecules to vibrate, so you can scream all you want, and no one will hear you. Classic. But that's where the boring definition of sound ends, and the truly weird part begins. The universe is screaming, whispering, and humming with energy. It's crackling with magnetic fields and sizzling with plasma waves. We just don't have the right kind of ears to hear it. But our instruments do. We've built probes and satellites that can detect these electromagnetic vibrations, and with a little bit of technical wizardry, we can convert them into a frequency that our pathetic human ears can process. We can make space audible. And when we do that, the universe sounds less like a silent void and more like a celestial haunted house. So let's take a tour of the universe's greatest and most unsettling hits. Imagine a storm so massive it could swallow the entire Earth whole. Now imagine that storm has been raging continuously for at least 300 years. That's Jupiter. It's not just a big, pretty striped ball. It's a planet of perpetual world-ending violence. And in the middle of all that chaos, it's crackling with lightning. But this isn't the kind of lightning you see on a summer night. This is lightning on steroids, superbolts that flash through clouds of ammonia and water ice. So what does it sound like? Well, in 1979, the Voyager 1 spacecraft flew past Jupiter and used its plasma wave instrument to listen in. It didn't hear thunder, of course. Instead, it picked up the radio signals that these lightning bolts produce. When scientists converted these signals into audible sound, they got something strange. It's not a crash or a bang. It's a quick, descending whistle like the sound of a cartoon bomb falling from the sky. It's a sharp pew. This sound is created by something called a Whistler wave. When a lightning bolt flashes in Jupiter's upper atmosphere, it sends a burst of electromagnetic energy traveling along the planet's powerful magnetic field lines. As this energy travels, different frequencies move at different speeds. The high frequencies arrive first, followed by the low ones. When you translate that signal into audio, your ear hears it as a descending whistle. Pee. The first time they heard it, scientists were ecstatic. It was concrete proof of lightning on another planet. But there's a slightly unsettling layer to it. Each whistle represents a bolt of lightning far more powerful than anything on Earth. So when you listen to the Voyager recordings, what you're hearing is a chorus of these falling tones, one after another, like a relentless cosmic arcade game. You're listening to the ceaseless, violent weather of a world that would obliterate you in an instant, and it sounds kind of quirky. It's the soundtrack to a planet that is actively trying to tear itself apart, and it's a catchy little tune. All right, let's bring it a little closer to home. You might think our own planet is a bit more musically inclined. Maybe some gentle whale songs, a nice breeze. Spa day in space kind of vibes. And you'd be right in a way. Earth has its own signature sound, but it's not exactly soothing. It sounds like a flock of deranged robotic birds waking up at sunrise. Scientists call it the dawn chorus, not because it's a beautiful symphony, but because it's most frequently detected by satellites during the morning hours on Earth. And the sound itself is a bizarre, overlapping cacophony of chirps, whistles, and squawks. If you played this in a forest, every bird in a 5-mile radius would probably pack its bags and move. It's a very weird, very alien sound, which is ironic, because it's 100% homemade. So what in the world is making our planet sound like an aviary for androids? This isn't a bolt of lightning or a distant star. The culprit is our own magnetic field, or magnetosphere, doing its job. Our planet is constantly being bombarded by the solar wind, a stream of charged particles shooting out from the sun. Our magnetic field acts like a shield, deflecting most of this cosmic radiation. But some of these particles, mostly energetic electrons, get trapped in the Van Allen radiation belts, vast rings of plasma that encircle the Earth. Think of these trapped electrons as hyperactive kids who've had way too much sugar. They're bouncing around inside our magnetic field, and under the right conditions, they generate these electromagnetic waves. The phenomenon is literally called a chorus wave. It's the interaction between the sun's energy and our planet's protective shield. So when you hear this chorus, you're listening to the sound of Earth's magnetic field in a constant, invisible battle with the sun. You are hearing the sound of our planet protecting us from being fried. It's the music of our own survival, and it just happens to sound like a flock of alien birds having an argument. For centuries, Saturn's rings were the ultimate symbol of silent, majestic beauty. They're this impossible, elegant structure. Trillions of pieces of ice and rock, some as small as dust, others as big as a house, all held in a perfect, razor-thin disk. They orbit Saturn in what appears to be a state of perfect, noiseless grace. It's the kind of thing that makes you feel small and insignificant in the best possible way. Then the Cassini spacecraft showed up and listened, and it turns out the rings aren't silent at all. They're screaming. Okay, maybe not screaming, but they are producing an incredibly complex and slightly unnerving symphony of sounds. When Cassini flew through the gap between Saturn and its rings, its radio and plasma wave science instrument recorded the interactions between the rings and the planet's own magnetic field. And the result is intense. It's a mix of crackles, static, and a strange rhythmic groaning, like an old wooden ship creaking under pressure. What you're hearing is the sound of chaos made manifest. Those trillions of ice and rock particles are constantly colliding, grinding against each other, and getting zapped by plasma. But the most distinct sounds come from what are essentially cosmic traffic jams. The rings are not a uniform sheet. They have waves and spokes and clumps created by the gravitational pull of Saturn's many moons. These shepherd moons, as they're called, carve out gaps and create density waves that ripple through the rings like grooves on a record. Furthermore, when tiny meteoroids, some no bigger than a grain of sand, slam into the ring particles, they instantly vaporize into a puff of plasma. Cassini's instruments could detect these tiny plasma clouds, and when converted to audio, each impact sounds like a little pop or crackle. So what you're hearing when you listen to the sounds of Saturn's rings isn't just one thing. It's a collection of a billion tiny events. The grind of ice on ice, the ripple of a gravitational wave, and the constant percussive pops of micrometeoroids dying a fiery death. It's the sound of a system that looks peaceful from a distance, but is pure, unadulterated bedlam up close. Before we get to this one, a quick, cheerful thought experiment. Picture a star much, much bigger than our sun. It lives its life, fuses elements, and then dies in the most violent way imaginable. A supernova explosion that briefly outshines its entire galaxy. What's left behind is one of the universe's most bizarre objects, a neutron star. This is the collapsed core of that dead star, a city-sized ball of matter so dense that a single teaspoon of it would weigh more than Mount Everest. Now, what do you think that sounds like? Well, in 1967, an astronomer named Jocelyn Bell Burnell was using a new radio telescope when she found something that baffled the entire scientific community. It was a signal from deep space that was pulsing with a regularity so perfect, so impossibly precise, that their first thought wasn't a star. Their first thought was aliens. They jokingly labeled the signal LGM-1 for little green men. It wasn't little green men, it was a pulsar, which is a type of rapidly rotating neutron star. These cosmic corpses spin at incredible speeds, some of them rotating hundreds of times per second. And as they spin, they shoot out powerful beams of electromagnetic radiation from their magnetic poles. If one of those beams happens to sweep across Earth, our radio telescopes see it as a pulse. It's the cosmic equivalent of a lighthouse. When you convert this radio signal to audio, it's not a melody or a roar. It's a rhythm, a beat, a perfect metronomic thump, thump, thump. That is more stable than any atomic clock we had at the time. You are literally listening to the heartbeat of a dead star. Each beat is the sound of an object the size of a city, with the mass of a sun spinning with terrifying speed and precision. It's the universe's most morbid drum machine, and it's a stark reminder that even in death, the cosmos is anything but silent. Okay, so we've heard lightning, planetary shields, dying stars, but what about the beginning, the ultimate origin story? The Big Bang. It's an event so monumental it's almost impossible to comprehend. A single point of infinite density that exploded into, well, everything. Surely an event that big must have made some kind of noise, right? The mother of all bangs. And it did. And we can still hear it. It is, without a doubt, the oldest and most profound sound you will ever hear. Don't expect a dramatic explosion, though. The sound of the Big Bang isn't a boom. It's a hiss, a quiet, persistent, uniform static that fills every single corner of the universe. It's called the cosmic microwave background radiation, or the CMB. It is, quite literally, the leftover heat from creation, cooled and stretched over 13.8 billion years into faint microwaves. In the early days, the universe was a hot, dense, foggy soup of plasma and radiation. Sound waves could actually travel through this primordial soup. But then, about 380,000 years after the Big Bang, the universe cooled enough for atoms to form. The fog cleared, the radiation was released, and it has been traveling through the expanding universe ever since. When radio astronomers first discovered this faint hiss in the 1960s, they thought it was a problem with their equipment. They tried everything to get rid of it. They even cleaned out the pigeon droppings from their antenna, thinking the bird poop was the source of the noise. But the hiss remained, no matter where they pointed their telescope. It was coming from everywhere at once. It wasn't noise in the machine. It was the machine of the universe. When you convert the CMB data into audible sound, it's just static. The kind of static you'd hear on an old analog TV that isn't tuned to a station. But inside that seemingly random noise is everything. It's the echo of the moment the universe became transparent. It is the oldest light, the oldest signal, the oldest sound in existence. You're not just listening to empty space. You're listening to the faint, lingering whisper of the birth of time itself. Let's tackle the biggest, baddest, most fundamentally silent thing in the entire universe, a black hole. This is where physics goes to die. An object with a gravitational pull so immense that once you cross its event horizon, there is no escape. Not for light, not for matter, and certainly not for a plucky little sound wave. A black hole should be the definition of absolute silence. It's a cosmic dead end. And yet in 2003, NASA announced that they had recorded a sound from a supermassive black hole, which is, a direct contradiction. So what's the deal? Did a black hole suddenly decide to violate its own rules just to mess with us? The story is a little more complex and a lot more interesting. The sound comes from the Perseus galaxy cluster, a collection of galaxies about 250 million light-years away. At the heart of this cluster is a supermassive black hole, and this black hole is active. It's periodically spewing out jets of material and energy. These jets travel through the hot gas that fills the entire galaxy cluster, creating enormous pressure waves, ripples of compression and rarefaction. Those pressure waves are, by a very literal definition, sound waves. The black hole is acting like a cosmic subwoofer, pumping a bass line through a cloud of gas the size of 1,000 galaxies. There are two problems, however. First, the sound is traveling through intergalactic gas, not a vacuum, which is how it exists. Second, the note is impossibly deep. It's a B-flat, but it's about 57 octaves below middle C. The frequency is so low that a single wave takes about 10 million years to complete. It is a sound so profound and so slow that it's completely imperceptible to any living thing. So how did we hear it? Scientists didn't hear it directly. They observed the ripples in the gas using NASA's Chandra X-ray Observatory. Then, to make it audible for us insignificant humans, they scaled it up. They raised the pitch by 57 and 58 octaves. They took a note that has been propagating for millions of years and compressed it into a few seconds of audio. What you hear is a deep, unsettling, ghostly hum. You're listening to the lowest note in the known universe, played by the universe's most destructive instrument. Comets are basically dirty snowballs. They're leftovers from the formation of the solar system, chunks of ice, dust, and rock that spend most of their lives in the frozen darkness of deep space. Then they swing in close to the sun, heat up, and put on a spectacular show, growing a glowing coma and a beautiful tail. They are silent celestial nomads on an epic journey, or so we thought. In 2014, the European Space Agency's Rosetta mission did something unprecedented. It didn't just fly by a comet, it entered into orbit around it. For months, Rosetta shadowed Comet 67P Churyumov-Gerasimenko, studying it in absurd detail. And its magnetometer, an instrument designed to measure magnetic fields, picked up something completely unexpected. The comet was singing. it's not exactly a chart-topping hit. It sounds like a strange, rhythmic clicking and fizzing, a sort of percussive electronic crackle. It's a deeply alien sound, which makes sense because it's generated by a process that could only happen in the weird environment of space. As the comet gets closer to the sun, its ice turns directly into gas in a process called sublimation. This process releases neutral water molecules, which then get ionized by the sun's ultraviolet light, meaning they get a positive charge. This cloud of charged particles interacts with the solar wind, that constant stream of particles flowing from the sun. This interaction creates oscillations in the magnetic field around the comet. These oscillations were what Rosetta's magnetometer detected. When the scientists increased the frequency of these magnetic field oscillations by a factor of about 10,000, it turned into an audible sound. The comet's song is the sound of its own atmosphere being born and simultaneously fighting with the solar wind. It's the sound of a dirty snowball waking up, and it's a surprisingly complex and rhythmic little tune. It's proof that you don't need to be a giant planet or a dead star to make a little noise in the cosmos. Everything we've talked about so far has been an electromagnetic wave converted into a sound wave. It's a translation, a clever trick to make the invisible visible to our ears. This next one is different. This is not a translation. This is the sound of space itself and time itself being warped and distorted by the most violent event in the universe besides the Big Bang. For decades, Einstein's theory of general relativity predicted something incredible. That when massive objects accelerate, they should create ripples in the very fabric of space-time. Gravitational waves. Imagine dropping two bowling balls onto a stretched rubber sheet and making them spiral into each other. The sheet itself would ripple. That's a gravitational wave. For 100 years, this was pure theory. The ripples were thought to be so unbelievably tiny that we would never be able to detect them. Then on September 14, 2015, two giant L-shaped detectors, one in Louisiana and one in Washington state, detected one. It was a signal that had traveled for 1.3 billion years to reach us. The source was two black holes, each about 30 times the mass of our sun, spiraling into each other at nearly the speed of light and merging into one. In the final fraction of a second, this collision converted 3 times the mass of our sun directly into pure gravitational energy, shaking the universe to its core. The LIGO detectors are so sensitive they can measure a distortion in space-time thousands of times smaller than the nucleus of an atom, and they caught the wave. When you convert that signal into an audible frequency, you finally get to hear what it sounds like when two black holes die. It's not a roar, it's not an explosion, it's a chirp. A tiny faint whoop that lasts less than about a quarter of a second. That little sound is the most powerful event ever recorded by humanity. It's the sound of reality itself, twisting and flexing. The sheer contrast is mind-boggling. An event of unimaginable violence, of two of the universe's most extreme objects destroying each other, and the sound it makes as it passes through our planet is just a faint upward chirp. It's the universe's ultimate lesson in humility. So after all this, you'd think we have a pretty good handle on where the universe's noises come from. We've got our pulsars, our black holes, our lightning, our leftover static from the Big Bang. We can point our radio telescopes at the sky, add up all the known radio sources, and the math should check out. The universe's books should be balanced, but they're not. In 2006, a NASA-backed experiment called ARCADE, which stands for the ridiculously long Absolute Radiometer for Cosmology, Astrophysics, and Device Emission, flew a giant balloon-based instrument high into the atmosphere to listen to the cosmos without interference. Its goal was to get a better look at the faint signals from the universe's first stars, but it found something else entirely. It found noise, a lot of noise. It's called the space roar. It's a diffuse, powerful radio signal coming from every direction, and it's much, much louder than it should be. After scientists subtracted the radio hiss from our own galaxy and all the known radio sources from distant galaxies, there was still this leftover roar. It's 6 times louder than all known sources combined. It's like walking into what you think is a quiet library, but there's a rock concert happening in the basement that no one can explain. So what is it? That's the fun part. Nobody knows. We are completely stumped. Theories range from the merely speculative to the wildly exotic. Could it be the combined scream of the very first stars, which were perhaps far more massive and numerous than our theories predict? Could it be a signal from the decay of some unknown dark matter particle? Could it be the overlapping noise of an uncountable number of extremely distant Faint radio galaxies that we just can't see individually? We don't have an answer. The space roar is a genuine cosmic mystery. It's a constant, powerful hum coming from the depths of space that defies our best models of the universe. It's a reminder that for all the incredible things we've managed to hear, the universe is still hiding secrets. It's still full of sounds we can't identify, a cosmic background noise that tells us our understanding is far from complete. We end with the most famous sound that we almost never heard. It wasn't recorded, it wasn't converted, and it wasn't analyzed for months. It was a ghost in the machine, a brief flash of data that has haunted scientists for nearly 50 years. It's not just a sound from space. It's a question from space, written in the language of physics. It's known as the wow signal. On August 15, 1977, a radio astronomer named Jerry Ayman was reviewing printouts from the Big Ear radio telescope at Ohio State University. The telescope was conducting a SETI project, the search for extraterrestrial intelligence. It was scanning the sky, listening for a very specific kind of signal, a powerful narrowband transmission. Natural cosmic sources tend to produce broadband radio noise, a messy splash of frequencies. But an artificial signal, a beacon from another civilization, would theoretically be clean, sharp, and focused on one frequency to maximize its power like a laser of sound. As Eamon looked over the data from a few nights before, his eyes froze. He saw a string of characters on the printout, 6EQUJ5. In the system they were using, this represented a signal that started low, rocketed up in intensity to over 30 times the background noise, and then faded away as the telescope moved past it. It was a perfect bell curve. It was a powerful narrowband signal that lasted for 72 seconds. It was exactly what they were looking for. Eamon was so stunned that he grabbed a red pen, circled the sequence, and wrote, "Wow," in the margin. And then, nothing. Astronomers immediately trained the Big Ear and other more powerful telescopes on that same patch of sky. They have returned to it countless times over the decades. They have never heard it again. It was a one-time only broadcast from an unknown source. Every natural explanation, from a passing comet to a satellite signal to a terrestrial source, has been investigated and has fallen short of explaining all the signal's features. It remains the single strongest candidate for an extraterrestrial signal ever detected. The wow signal isn't unsettling because of what it sounds like, but because of what it implies. It was a whisper in the dark, a brief, intelligent-seeming shout from the constellation Sagittarius that appeared and then vanished forever, leaving us with a single, tantalizing, and perhaps terrifying question mark. So there you have it, more proof that the silent, empty void you see in the movies is a comforting fiction. The reality is far stranger and much louder. The universe is filled with the groans of dying stars, the chirps of colliding black holes, and the unexplained roars from the dawn of time. If you want to find out what other shenanigans your reality is up to, make sure you're subscribed for the next video.